Again, in example 2, what we notice is that there is not an obvious variable for us to try to eliminate. If I try to eliminate x, what I notice is that there's no number that I can multiply 3 by in order for it to equal 7. Similarly, if I try to eliminate the y's, there's nothing that I can multiply 2 by that's not a fraction in order for me to equal 11. And so, therefore, what I'm going to have to do is multiply both of my equations by a constant. Again, you have the choice as to which variable you want to eliminate. But just to keep things simple, I'm again going to eliminate x. And so if I look at my coefficients for x, what's the first number that they could both meet up at and be opposite coefficients? Well, the answer to that would be 21. If you think about the larger number 7, its multiples are 7, 14, 21, 28, and etc. And the first of those that is divisible by 3 would be 14. And so what I'm going to have to do is multiply my blue equation by a 3 and my red equation by a -7 in order for these to be opposite coefficients. And so notice that right now they are the same sign. And so in order for them to be opposite signs, one of them is going to have to be multiplied by a negative. And so what I'm going to do here is I'm going to set up my 3-column approach, as I always do for the elimination method, and I'm going to multiply my blue equation by a 3. And so this is going to be 3 multiplied by 7x minus 2y is equal to -13. When I distribute that 3 to everything, I'm going to have 21x minus a 6y is equal to 3 times -13, which will be -39. That equation is going to get copied and pasted to the second column. 21x minus 6y is equal to -39. Then I'm going to take my red equation and multiply it by a -7. And the reason it's got to be -7 is so that we can have opposite coefficients. And so -7 times 3x minus 11y is equal to -36 is going to give us -21x plus 77y is equal to 36 times 7 is going to be 252. And notice that that number would be positive. We're then going to copy and paste that into our second column. -21x plus 77y is equal to 252. From there, we notice that when we add our two new equations, our 21x and our -21x will cancel out. And so therefore, adding everything else up, -6 and +77 will give me 71y, and 252 and -39 is going to give me a 213. Then dividing both sides of that equation by 71, y is going to equal to 3. So we have half of our solution. We are now ready to find the other half in column 3. And so we can take either of the first two equations, the original equations given in the question, and solve for x. And so what I'm going to do is take the blue equation, 7x minus 2 times y, which we found in the second column to be 3, is equal to -13. So what we have is 7x minus 6 is equal to -13. Adding 6 to both sides will give us 7x is equal to -7. And dividing both sides by 7 will give us x is equal to -1, which tells me that the solution for this system of equations is the ordered pair -1, 3.